Hello, welcome to this video. In this video, we'll be looking at the intersection of lines and perpendicular distance of a point from a line. So let's work that out with this example. So we've been asked to prove that these two lines intersect and then to find the coordinates of their point of intersection. So first thing we're going to do is write the equations of these lines in parametric form. You see that for the first line, we'll start by writing it in vector form. You see that the point on the line is -1, 0, 5 from the numerators, and the direction of the line is 1, 1, negative, 1, 1, negative 1. So in parametric form, this would be x is equal to -1 plus lambda, y is equal to lambda, and z is equal to 5 minus lambda. For the second line, you can see that its equation is going to be 3, 1, 4 as the point on the line. We'll use a different parameter there, mu, to -1, 1 being the direction. So here we'll have our x as 3 plus 2 mu. We'll have our y as 1 minus mu, and our z as 4 plus mu. Okay, so now what do we do here? Since the lines are to intersect, we want to prove that they intersect, then we're going to have to solve these equations simultaneously. So we'll pick two pairs. We could look at the ones for x and the ones for y, find the value of lambda and mu, and if they are consistent with the equations for z, then we'll have shown that those two lines indeed intersect. So we'll have -1 plus lambda is equal to 3 plus 2 mu. In our first equation, this means that lambda is equal to 4 plus 2 mu. And then the equation for y is that lambda is equal to 1 minus mu. So we can simply just go with 4 plus 2 mu is equal to 1 minus mu. This gives us our mu as -1 when we solve. And after that, we get our lambdas too. Now, if we check for z is supposed to be 5 minus lambda, which is 5 minus 2, which is 3. If we check using mu, we'll have 4 plus mu, which is equal to 4 plus -1, which is equal to 3. So the values lambda is equal to 2 and mu is equal to -1 are consistent for these three pairs of equations. Therefore, the two lines intersect. That's the logic behind it. The two lines intersect. And okay, how do we find the point of intersection? We simply substitute. We could either use, the values for lambda or for mu to get the point of intersection. We'll have that x is equal to -1 plus 2, which is 1. Y is equal to lambda, which is just 2. And we already know that z is equal to 3. So the point of intersection of those two lines is in fact 1, 2, 3. Okay. Now, I want to look at angle between two lines as well. Now, the angle between two lines is simply the angle between the directions of the lines. And so if we have this as the direction of the first line, the direction of the second line, we can simply use the dot product to find the angle between the lines, because we know that the dot product of two vectors is equivalent, so is equal to the product of the magnitudes of those two vectors and the cosine of the angle between them. So in this case, we have that our dot product for the two lines or so, we know the direction of the first line is 1, 1, -1, and the second line is 2, -1, 1. Find that dot product, that's going to be 1 times 2, which is 2, plus 1 times -1, plus 1 times -1. This gives us 0. But we know that for if the dot product of two vectors is 0, then those two vectors must be perpendicular. So the angle between the two lines is 90 degrees, simply because their dot product is 0. However, if the dot product wasn't 0, then we'd have to go ahead and find the magnitudes of the directions and then find cos theta using this equation here. But since we have it as 0, we can just go ahead and conclude the angle between the two lines is 90 degrees. So that's how we find the angle between two lines. Okay, we want to look at perpendicular distance of a point from a line. We'll use an example to handle this as well. So we have our line, and then we have a point, and the distance that we want to find is that distance right there, such that this vector or this line segment there makes 90 degrees with the line. So we have our point T in space, 4 to 2. We have a point P on the line. We could call it X naught, Y naught, Z naught, such that TP is perpendicular. TP is perpendicular to the line. And being perpendicular to the line, therefore, means that it's perpendicular to the direction of the line. And so when you dot TP with the direction of the line, you should get 0. Okay. So this is the equation that's actually going to lead us to get our answer. Remember, the question was the perpendicular distance. So the question is basically asking, what is the magnitude of the vector TP? Okay. So first thing we're going to do again is write our equation of the line in parametric form. This is going to be x is equal to 3 plus lambda, y is equal to 1 minus lambda, and z is equal to negative 1 plus 2 lambda. Now, of course, for our special point, which is x naught, y naught, z naught, could have a particular lambda value, lambda naught, that satisfies all the equations there. And so we find the vector TP. The vector TP we know is OP minus OT. What's our OP? Our OP is 3 plus lambda naught, 1 minus lambda naught, negative 1 plus 2 lambda naught. We're subtracting 4 to 2. So this gives us negative 1 plus lambda naught, negative 1 minus lambda naught, and minus 3 plus 2 lambda naught. Sorry, I can't write it there. But yeah. So we dot that with the direction of the line. The direction of the line is simply 1, negative 1, 2. And we should get 0. So negative 1 plus lambda naught, negative 1 minus lambda naught, and negative 3 plus 2 lambda naught. When we dot that with 1, negative 1, 2, we should get 0. So this will give us an equation in lambda naught, negative 1 plus lambda naught, plus 1 plus lambda naught, minus 6 plus 4 lambda naught, is equal to 0. And immediately when you solve for lambda naught here, you get lambda naught as 1. So you go ahead and substitute this in the expression for TP, such that we can get what the vector TP is. Therefore, TP will be negative 1 plus 1, which is 0, negative 1 minus 1, which is negative 2, negative 3 plus 2 times 1, which is negative 1. And therefore, the magnitude of TP, which is the perpendicular distance of the point T from the line given, in fact, square root of 0 squared plus negative 2 squared plus negative 1 all squared, which gives us root 5 units. That's how we'll get your answer. Okay, in our next video, we'll be looking at the plane.